If you need to create curves that follow a specific set of data points, the Curve Through XYZ Points tool is the way to do it in SOLIDWORKS. Suppose I'm working on a propeller design, and I have a document containing specifications for the blade shape as it extends toward the tip of the propeller. I want to create profiles using these data points, and then use a loft to create the blade geometry. The Excel file I have gives me the X and Y point data for the profile curves at every 6-inch interval along the blade. So the first thing I'll do is create planes, offset from the front plane. I'll choose 6 inches for the distance, and create 6 inches of the plane. This gives me the planes I need to locate the profiles. Let's create the first profile. I'll go to Insert, Curve, and choose Curve Through XYZ Points. This brings up the Curve Through XYZ Points dialog box where I can specify the point data. Now the easiest way to use this tool is to browse for an Excel or Tab delimited text file and let SOLIDWORKS import the values for you automatically. However, in order for SOLIDWORKS to do so, the document has to be formatted so it contains exactly 3 columns. One for X, one for Y, and one for Z. Unfortunately, this Excel file is not formatted that way, so I can't simply import the values. I'll have to enter them by hand. I'll start with the profile at 6 inches. I'll simply key in the values from the spreadsheet for X, up or Y, and for the Z value, I'll choose 6 inches. You can see a preview of the curve start to appear as I key in the values. Once I have all the values entered, I'll save the curve quickly because I'll be reusing the X values for the lower half of the curve. And with the curve saved, I'll finish it up and insert it into the part. Now I'll repeat the process for the lower half of the profile. I'll go to Insert, Curve, Curve Through XYZ Points. Now I can hit the Browse button and browse to the curve I just saved. When I open it, you can see the point data loads up into the window. I can edit the Y values and replace them with the values for the lower half of the curve. I'll finish it up and the first profile is almost complete. Notice that there's actually a small gap between the curves here. I'll need to close this gap in order for the loft feature to recognize the curves as a closed profile. I'll start a sketch on plane 1 and use Convert Entities to convert the curves into sketch entities. Next, I'll use a tangent arc to connect the 2 endpoints of the curves and close the profile. Now I choose to use a tangent arc because I don't know the exact point data needed here. But keep in mind, you can use a spline and dimension the control handles to get more control over the exact curvature here. Once the profile is closed, I can exit the sketch. I'll repeat the process to create the second profile, this time using 12 instead of 6 for the Z value. To close the profile, I'll again start a new sketch, this time on plane 2, and use Convert Entities, along with a tangent arc to close the profile. Now I need to repeat this process for all of the remaining profiles, which would take a little time, so instead, let's skip ahead to creating the loft. I'll exit the sketch and launch the loft feature. All I need to do to loft the geometry here is select the profiles, but I want to make sure they don't twist. Now, if I just click anywhere along the curves, the preview could potentially twist based on where I select, and I could get errors. So when I'm making my selections, I'll be sure to select the center points of the tangent arcs. This will minimize the twist and leave me with a clean lofted blend between the two profiles.